All right, so I'm live with 52 weeks of AWS. It's been a minute, but I'm back. And one thing I'm going to mention real quick is the book on developing AWS with C Sharp is out. I wrote this book with James Charlesworth, an amazing author, and there's a lot of really good stuff on AWS here that you may be uh, open to hearing about, including even if you're not a C Sharp developer. So just wanted to mention that, and you also can get it for free on the AWS website as well. So free book on AWS, definitely would recommend it. All right, let's get right into it here, and I'm going to talk about developing solutions with Amazon API Gateway. So I'm going to continue to do the AWS developer certification training material. So to start off with here, we're going to dive into API Gateway, which is a pretty fun product on AWS that a lot of times you'll use with serverless applications. So let's dive right into it. In terms of application programming interfaces here, here's a good overview. So to start with, we have a RESTful API and we have a request response cycle. So we have a client. The client does a get, a post, a put, a delete, and these are all HTTP methods. And when you are going to communicate with a server, this is the language that you're going to use. So when would you do this? Online transactions, blogs, social media. There's also bidirectional, which is a pretty interesting technology that I've played with in my past. And you can do a push as well as a pull. And so in this case, in terms of a WebSocket, you could have a chat application, for example. This would be probably one of the best examples of it. Real-time dashboards, real-time alerts. These are all things you get from WebSocket. So here's an example here of a simple RESTful API. In theory, what happens is that, let's say you wanted to create a real estate application. A user goes to the website and they enter a search criteria like the city or the neighborhood, property type, etc. You would then make a REST API inside of the front end. A more complicated example would be that you have a web client and you've got a mobile client, and they are able to communicate via a API call from the application. So in the case of a mobile client, there could be special URLs actually for the mobile client. For example, maybe you don't want to accept as much data because the mobile client will not be able to actually view all of the real estate. And so you could have a slightly different API endpoint for mobile and web, or you could use the same endpoint but with some kind of a filter that would show the difference between those two applications. And then if you wanted to go to even more complicated scenario here, you could have the web, you could have a mobile client, and then you could also open up your ecosystem to a third-party API call. In fact, I've built something like this before. When I built Sports Social Network, we had a web front end, we had a mobile front end, and then we also had a third-party API so that our partners, when they're communicating with us, they could build on top of it. In fact, we even had fourth system on top, which was we would have a business application that also talked to the same API. So you can have many different types of users all talking to the same endpoints. So if you wanted to scale and manage the versions, this is where things get a lot more complex with APIs. So on one hand, you have to handle the spikes in traffic. You also need to track how many API calls are being done by clients. So it's very easy to abuse, for example, a website by hammering it over and over again, or somebody's scraping your content. And so one of the ways you could do this is have rate throttling set up so that you don't actually have people abusing your application or abusing your API calls. And that's something you can do by using Amazon API Gateway. So what is it in a nutshell? It's a fully managed service that lets you create, publish, maintain, monitor, and secure APIs at any scale. So you can use it to create a REST, or you can create web service or a WebSocket API. And the applications can then go back into AWS and get access to things like EC2 instances or Lambda. And what's great is there's no minimum fee or startup cost. So this really does solve a pretty significant problem that has been quite tricky for some time in the web development world. Another thing to be aware of is that you only pay for the calls that you receive, and also it can accept hundreds of thousands of concurrent API calls and do things like traffic management, authorization, access control, etc. So here's some of the benefits of using the API gateway service. One of them is making efficient API development calls. So you could create a custom API, for example, to run code that talks to Lambda. You could also do support for RESTful and WebSocket APIs from the same endpoint, and you could enable that bidirectional view. You also have built-in resilience because the API gateway has throttling rules, and you can also handle any level of traffic. You can automatically scale up. There's also lifecycle management with API gateway, so you can control what version of the SDK that you use. You could even generate an SDK, which is pretty cool, right? If you wanted to give that to a mobile developer that's a partner, you could just give them your API via the SDK. Also, API operational monitoring. So after the API is deployed, you could also have a dashboard that visualizes everything that's happening, and you get that for free. Authentication comes in as well. And then there's also the ability to do API keys for third-party developers. So really, these are all very tricky problems to solve that I've had to do in different parts of my career, and you just get it for free by using API Gateway. You also could use it to provide an API for your applications themselves. So here's a good example where you could have these different clients, and those clients talk to API Gateway, and then on the back end, these managed services are all communicating with API Gateway. And what's nice about this is that you don't have to actually manage potentially the services that are in using API Gateway. If you use serverless, for example, you could completely get rid of all of the scaling aspects of writing backend code. It would all basically be waiting there until you made a request, and then everything would activate. Another thing to be aware of is that the development of both the WebSockets API and the REST can get started with this process of first creating an API, then controlling access to it, then testing it, then deploying and configuring the API, invoking it, and then monitoring it. So let's talk about what would be involved with creating a RESTful API. So a few things to be aware of is that an API gateway, a REST API is a group of resources and methods. So in this example here, we have the resources would be pets, pet food, pet toys, and then the operations, these would be the web operations here. HTTP operations would be get, patch, post, delete, and put. And so you can use them together, right? So you have the resource and then the way to operate on the resource. So a good example would be a get is when you're grabbing something, like if you go to the front page of somewhere and you just go to the website, you're going to be using typically a get. If you're going to be sending data like a credit card form that you filled out, you're most likely going to do a post. So in terms of API endpoints here, when you build one, you have to select an endpoint type. And so an API endpoint is the URL where the API is deployed, and it refers to the host name of the API. And so it could even be edge optimized, which is a nice way to reduce the latency to the API. And this really can be a big deal if you don't have the ability to have low latency APIs. It could be very difficult to use your application or use your API. Also, regional API endpoints, which is pretty nice. So they can be in the same region as your resources. And then finally, private API endpoints as well. So in terms of API methods and integrations, the client would have a public interface, and then there could be a internal interface. And so the method request where the API gateway interacts with the client is making that request, and it would reshape it based on what it is you needed to do. So let's talk about some of the models and mapping to the templates here. And so in API gateway, a request and response messages are transformed and validated between the client and the back end, and the model would define the data structure of a request or a response. So here's a good example of what the JSON looks like here, where you have a particular property that has price, size, units, and it has the type built in there as well. So let's talk about how to control access to a RESTful API. So it's one thing to build an API. It's another thing to actually control access to it, essentially make it a production-based system. So some of the ways you can do this, one of them is with a uh, access control for REST API. So API Gateway can allow you to secure your API using things like IAM, which is pretty nice because you can build into the existing security infrastructure. Also, there's a resource policy. So you could have a JSON policy that attaches to an API. You could do a Lambda authorizer. So this would be a bearer token like OAuth. You could do Cognito user pools. You could also do cores. And you could also do SSL certificates. So there's a bunch of different layers of security that are all built in and are best practices for building APIs. All right, what about testing an API? So let's talk about some of the things that you would do for that. One of the ways that you could test an API is by going into the console, which does make it really nice, is that you don't have to have a huge test infrastructure. You just log right into there, look at what's happening, see the JSON payload that's returned, and just verify that things are actually working. What about deploying a RESTful API? So one of the nice things about the API Gateway is that the stages are snapshots or versions of the API, and they could be different as the API evolves. So you don't have to make an all or nothing change. You could leave up a different version of the API endpoint, which is really nice when, for example, you're making changes to the schema of a database, for example. This is a very classic one. And then you have a totally different version, right? You could have multiple RDS servers, and you could have infrastructure as code that can manage it. And then you could leave the existing relational database there, talking to an older API, and then push out a new version to make sure that it works first. In terms of enabling API caching to enhance responsiveness, this is another thing you can do. So you can cache the endpoint's response, which is really nice to be able to have that capability. And you can actually cache the API responses by using an Amazon CloudFront distribution that's closer to the client. So you can basically create a edge optimized endpoint. Another thing you could do, which is, again, amazing that you can use this service, is you get API request throttling. So there's many scenarios where you do not want people to be hammering your website with unlimited requests, because it could basically take your website out or your API out. And so instead, you can have a rate throttling, and you could say, for example, there could be a maximum of 50 requests per day, and you could have a quota of, let's say, 10,000 API requests per second. So, sorry, 50 requests per second, and then 10,000 per day would be as a good example. All right, now how do you invoke a RESTful API? So a few things to consider here is, once you deploy an API, you can submit it by having a request to the URL. And so the base is where the API was deployed. You can see here, this is API-ID, execute API region, Amazon AWS.com stage. And then the stage is actually the part that's going to change based on what version that you're going to push out. So the other thing to be aware of is that in this particular example, we have a JavaScript API invocation example. And you can see here in the JavaScript, the first part is extract endpoint and path from URL. The second one is create an API gateway client instance. And then finally invoke the get method based on the previous setup. Now, what about monitoring? Really important in a real world system is to have monitoring. Well, in terms of monitoring APIs, you can monitor via CloudWatch. You can collect and process the raw data from an API gateway into essentially real-time metrics, which is also awesome that you don't have to set up a completely separate monitoring system. So you can monitor things like count. So like how many times was your API called, the integration latency, the latency itself between the API gateway and the clients, the cache hit count. So like, is your cache even being used? The miscount, the HTTP errors, like 400 and 500 errors. So again, really basic stuff that typically takes a lot of time, just is built right into API Gateway. So really that's it for API Gateway. And I think the main thing to take away here is that when you're dealing with a service like API Gateway is that it's solving a ton of problems that you typically would have to do in the real world. And I've actually had to deal with these kinds of services quite a bit in my career and build these kinds of systems. But if you use API Gateway, it's completely done for you. All right. So that is API Gateway. In a couple weeks, I'm going to dive into step functions. There's only about 3 more lessons here left. 2 weeks from now, I'll cover AWS step functions. And then 2 weeks after that, develop secure applications. And then we'll wrap it up with deploying applications. All right. Talk to you soon. I'm out.